This lecture we continue learning forecasting. In a former video, we have discussed the why and what dimensions of forecasting. We have discussed what forecast is and why it's so important in a business. This lecture will focus on the how dimension. We will discuss the detailed methodology, the detailed tools we can use to improve the forecasting in business. In general, there are two types of forecasts. One is quantitative methods and another is the quantitative methods. For the quantitative methods, it heavily relies on the experts or the professional person. It according to the comments or the ideas or the research or the information you obtain for the experts to make the decisions about how much of the units you should produce and how much of the units for a specific product you should ship to a retailers to sell to customers. So in order to obtain the correct information for experts, a key task for you is to ask the right questions. And another type of the forecasting method is what we call the quantitative methods. And for the quantitative methods, we still have two categories. One is called correctional models, while another called time series model. For the correlational models, a very famous tools we use is regression. So if you can find a variable which has the impact on the factors you want to forecast, then you will be able to use regression to have the number you want to know. And for the time series model, when you have the historical track record of the variable of the data you connect, namely if your primary source of data is the historical track record of the variable being predicted, then you can choose the simple, like the basic time series models. One is what we call the moving average and another is exponential smoothing. For those two models here, you don't need to connect a lot of data and you don't need to use a complex math because the data, the forecasting you want to make is straightforward. For example, if we think back to the data pattern, if your data pattern fits the horizontal pattern, which means all the data you connect fluctuate the mean, like across the mean or across the average, you can use those two simple ways to make forecasting. This video will focus on the time series model and we start with the moving averages. So what is the moving average? The keyword is moving. So we know the average, but what is the moving average? It means like we need to choose a moving data as the basic data set for us to compute the average. And we have two ways to calculate the moving average. One is what we call simple moving average. So we just sum the data we care about and to compute the average. And another one is what we call the weighted moving average, except for like sum all the data together, and to compute the average we need to consider the different weights for each data we choose, and we will introduce that later. So let's begin with the simple moving average. Specifically, the formula we use to compute the simple moving average as the forecast data we used for a period t plus 1 is as this formula listed over there. T plus 1 names like you want to make a forecast for next time period if you have the actual demand for current period T. And because we use moving average, so this is not only focuses on the average but focuses on the how many data you want to choose in your computation. If you want to choose 3, then you need to have 3 data have 3 the historical data at least to compute the average. So let's make it clear in terms of moving. So for example, we have 5 time period. So time period 1, 2, 3, 4, 5. And we think about a 3 moving average, which means we want to choose 3 data to make forecasting for the 4th time period. So if you want to make a forecasting for time period 6, and currently you only have the data for period 1 to 5, and you want to make a forecasting for period 6. If it is a 3 moving average, we need to choose the data for the former 3 periods. So for the period 6, the former 3 periods will be period 3, period 4, period 5. So we sum those data for those 3 periods together and divide it by 3. Then we will have the average number for the 3 time periods, and then we will be able to obtain the value for the period 6. Then what is moving average? So if you already have the actual number for period 6 and you want to make a forecasting for period 7, then for period 7, the average you need to compute is the average for the period 4, 5, and 6. So this is the moving, like when you want to compute the forecasting for a period, you need to obtain the most recently data for that time period. So for simple moving average, one of the things you need to consider is about the period. What kinds of moving average you like to use? 3 moving average, 4 moving average. The 3, 4 here represent how many periods you should have at least if you want to make a forecasting for the next period. So this is a general way we compute the simple moving average. This is a general formula here. The DT here stands for the actual demand in periods, and N here represents the total number of periods in the average. If you choose 3, this is equals to 3, 4 equals to 4, 2 equals to 2. It depends on how many periods you consider. And the F T plus 1 indicates the forecast for period T plus 1. So let's take a look with an example. The table here shows for the week 1, 2, 3, how many patients arrival in a medical clinic. And according to the table here, according to the arrivals for the past 3 weeks, we are asked to compute the week for arrival patients via a 3-week moving average forecast. So how to obtain the forecast via a 3 moving average for week 4 because we have the past 3 weeks the actual patient's arrival. So for the question A, we just sum all the actual patients' arrivals together and divide it by 3 because this is a 3-week moving average, and we obtain the average here, the average value for the first 3 weeks, and the average value here will be the forecast for week 4. It means like in week 4 we predict that it will have 397 patients arrival. And for the question B here, if we know the actual number of patient arrivals in week 4 is 415, what is the forecast error for week 4? Here I need to analyze what is forecast errors. And this is also the concepts we need to introduce in detailed nature. I can give you a brief understanding about what forecast errors is. Briefly, the forecast errors is the differences between the forecast you made and the actual number. So it is always the difference between the actual and the forecast. So for question B, if we know the actual arrival, the patient's arrival is 415, then we use 415 minus what we have made the forecasting, the 397 for question A. The 18 is the forecast errors. And for the question C, what is the forecast for week 5? We still use a 3-week moving average. And for the question C, we can analyze the moving clearly because for the week 4, because we only have the 3 weeks numbers of the patient's arrivals here, so when we want to make forecasting for week 4 via a 3 moving average, we just like saw the average, we didn't see the moving because we just used like the numbers here. But if you want to compute the week 4 forecast, so now we already know the week 4 the actual patient's arrival is 415. So if we wanted to compute the week 5 possible patient's arrival, we need to consider the actual arrivals for weeks 2 through 4. So for the week 4 forecast, we consider the week 1, week 2, week 3, and if we wanted to make a forecast for week 5, here is the moving. So we're moving the average to the next time periods. So we consider the 2, 3, 4, we just sum those actual patients together and divide it by 3 to obtain the average. And then we have the forecast for week 5. So this is what moving average talks about. So for week 5, we use 415, which is the actual patient's arrival in week 4, plus 111, which is the actual patients for week 3, and 380, the actual patients in week 2, and divided by 3 because we consider a 3 moving average. We sum through the most recently historical data, and then we obtain a 402. This is the forecast for week 5. And why it is called the simple moving average, because I will introduce what is the weighted moving average. So take a look with the formulas here we use to compute the forecast for week 5. If we change a little bit the formulas, and we will obtain F5 equals to 1/3 times 450 plus 1/3 times 411 plus 1/3 times 380. So we just change a little bit the formula. So we obtain a new formula over there and take a look with the numbers here. So why we call it a simple moving average? If we regard the 1/3 as the weights for each time period we considered, we will see that the weights for each period are the same, which means we don't involve any weights into the different periods, even though the week 4 is the most recently historical data for week 5. But the week 4, week 3, week 2, they have the equal weights when we consider the week 5 forecasting. So this is what we call simple moving average. And if we consider what is the weighted moving average, we still look for the moving average. We still consider how many periods we should consider and how to move the numbers of the different periods to make forecasting for the next period. But we don't use the same weights for each time period. We have the different weights for different period we considered. And the weights we use W to represent the weights for each time period, and W1 represents the most recently weights. The weights for the most recently period. So let's take a look with an example. Still the same example, we have the patient's arrival in a medical clinic, and we have the data for the first 3 weeks, and we want to make a forecasting from week 4. It should be week 4, sorry. For week 4. But comparing with the simple moving average, now we prefer to use weighted moving average. So for this example to here, except for the tables here, it also provides the weights we need to use to compute the moving average. And W1 here represents the most recently the weights for most recently periods, and this is for the second recently period, and this is for the third recently period. So instead of use 1/3 as the weights for each period as a simple moving average, if you use a simple 3 moving average, we use 0.5 as the weights for the most recent periods, and 0.3 for the second most recent, and 0.2 as the weights for the third most recent. So we still use 3 moving average, but we don't use 3 moving simple average. We use the weighted 3 moving average. So we use 0.4 times 411, which is the most recent number, and we plus 0.3 times the patient's arrivals in week 2, and use 0.2 times the 400, which is the patient arrivals in the week 1. So we obtain a forecasting for week 4, which is 399.5. So this is how we compute a weighted moving average. Instead of use the same weights for each period, we considering the most recent period may have a higher impact on the forecasting for the period we want to make forecasting. So this is how we use moving average. And the same if we know the actual patient's arrival in week 4 is 415, we're able to obtain the forecast errors. And if we know the actual patient arrival in week 4 is 415, we can compute the forecasting for week 5. And we just use the 0.5 times 415. This is the actual patient's arrival in week 4. And this is the weights for the most recent. And 0.3 times 411 and 0.2 times 380, and we obtain the forecast for week 5. So this is the first time series model I'd like to introduce about the moving average. We have simple moving average, which the weights for each period are the same, and the weighted moving average, we consider the different weights for different periods. And the second tool I'd like to introduce for the time series model of forecasting is exponential smoothing. Exponential smoothing focuses on if you want to smooth out noise, because if you connect a lot of historical data, the data for last year may have a very rare impact on the forecasting for this year. So if you want to smooth out of noise, or if you want to catch new trends quickly, exponential smoothing will be a very useful tool. And it helps you to do this by weighting your last period's demand with your last period's forecast. So we have a weight here we call alpha. So if you want to smooth out of noise, which means you believe the demand shifts are temporary, so you have a very small number, a minimum weight for the actual demand. If you think that the unexpected changes in demand reflect the future trends, then you have a higher value for the alpha. So anyways, the exponential smoothing helps you to obtain the forecast for the next time period while weighting your actual demand this period, the current period, and the forecast demand for current period. So if you know the forecast for current period and you obtain the actual demand for the current period, you will be able to make the forecast for the next time period. What kinds of objective you want to achieve? If you want to smooth out the noise, you choose a minimum value for alpha. If you want to catch new trends quickly, you choose a higher value for alpha. For example, if we want to use the smoothing forecast for next Monday, which means we choose a minimum alpha, a small value for the alpha. For the actual demand, we want to smooth the noise. So for the next Monday, the forecast will be the 0.3 times the 40. 40 is the actual demand this Friday, plus 0.7. 0.7 is 1 minus. Here is 1 minus alpha, which means 1 minus 0.3, and 0.7 times 45.36, which is the forecast demand for Friday. And then you will be able to obtain the forecast for Monday, which is 43.75. And I still have the example for the same with the same numbers we have for the patient's arrival of a medical clinic. If we know the actual patient's arrival for the past 3 weeks, and we want to use exponential smoothing to compute the forecast for week 4. And we use an alpha equals to 0.1. So how to calculate the exponential forecast for week 4? We know that if we want to use the exponential forecast, we need to know at least the actual demand and the both demand. But for this example, we do not have the forecast demand. If you face that situation in a real business, what can you do? The actual demand is the data we can connect. So the only thing you need is the forecasted demand. Then you just need to make a forecasting for the period you want to use. For example, for the week 4, if we want to use the exponential smoothing, we already have the actual demand. Then we need to analyze what is the forecasted demand in week 3 because we want to make a forecast for week 4. They are in general have 2 ways. On one hand, use the average of the first 2 weeks of the demand as the forecast for the week 3. For example, for this specific problem here, because we already know the actual demand for week 1 and week 2. So we just use a simple average for these 2 weeks as the forecast number for week 3. Then we will have the forecast number for the week 3. We use 400. This is the actual patient's arrival in week 2 and 300. No, in week 1 and 380. This is the actual demand in week 2. We compute the average for the first 2 weeks as the forecast for week 3, and then we have the forecast the actual patient arrival for week 3. We use the alpha, the 0.1 times the actual patient arrival plus 0.9 times the forecast patient arrival in week 4 as the forecast for week 4. Another way you can obtain the forecast, if you only have the actual demands, you can simply use the actual demand also as the forecasted demand. But note that you are not able to begin tracking forecast errors for the second period. You can do that for a second period because we just use the actual demand for the week 4. So which means week 4 we don't consider about the forecast errors. We will start to calculate the forecast errors for week 5, the second period we compute. So this is about the exponential smoothing. And this is another time series models I'd like to introduce. And the last thing for this videos I'd like to introduce is about the forecast errors. Actually, except for the value we obtain for the differences between the actual and the forecast numbers, we have 3 measurements for us to evaluate how the forecast is. Those 3 measurements help us to evaluate the forecast accuracy. And this is the last thing I'd like to introduce. So for the mean absolute deviation, what we call the MAT, we compute the forecast errors for each period, and we choose the absolute value for the forecast error. The actual minus the forecast is what we call forecast errors. So MAT, this measurement equals to the average of the absolute value for forecast errors for all the periods you make forecasting. And the MSE here, we use the forecast error square instead of the absolute value of forecast errors. to evaluate the forecast accuracy. And for the MAP, the MAPE, we use a percentage. What kinds of a ratio we pursue? We use an absolute value of a ratio. The ratio here is the forecast errors divided by the actual value. We use those ratio, the absolute of this ratio, we pick up the average for all the periods we considered as another measurement we use to evaluate the forecast accuracy. So in general, we have these three measurements to assess how the forecast is. The basic idea for these three measurements are the same. We want to know the forecast errors. We want to know the average forecast errors, but we pick up the different types of the forecast errors. The MAT, we use the absolute value. The MACE, we use the square value of the forecast errors. And the MAPE, we use a ratio for the forecast errors with the actual values, and we pick up the absolute value. So let's take a look with an example here. If we know the demand, the actual demand for the month 1 to month 8 as listing in the second column, and we know the forecast value for month 1 to month 8, then we will be able to know the forecasting errors. So we always note that we always use the actual minus forecast. So we always use the 200 minus the 225. We use 240 minus 220. We always use the actual minus the forecast, and we will able to obtain the forecasting errors. And then according to the number here, we can calculate the square number, the square value for the forecast errors. We can compute the absolute values for forecast errors. We can compute the absolute percentage of errors. We just use the forecast errors divided by the actual demand. We use, for example, for month 1, it equals to the negative 25, which is the forecast errors we obtain here, divided by the actual demand, which is 200, and times 100%. So we will obtain 12.5% as the absolute value here. And how to obtain MAC, MAD, and MAPE? The MACE equal to the square root of forecast errors divided by how the number of period we consider. So we use the sum of the square roots of the square of the forecast errors divided by 8. We obtain 659.4. And for the MAD, we only consider the absolute value of forecast errors. So we use 195 divided by 8, and we have 24.4. And for the MAPE, we considering the absolute value of the forecast of the ratio for the forecast errors and the actual numbers. So we have 10.2. The 5,275, the 195, the 81.4 comes from the summation. So this is the sum for all the A months of the square of the forecast errors, and 195, this is the sum of the absolute value of the forecast errors, and the same, this is the sum for these last columns for all of the A months. So we just calculate the average for all of the A months here, so we obtain the numbers. The 659.4, the 24.4, the 10.2%, They are the numbers. So what kinds of information we obtain from those numbers? First, according to those numbers here, we know how far off your forecast for the actual happened. And another thing you can do is like you compare your numbers you obtain for here with the benchmarking in your areas to compare those two numbers and help you to improve the future forecast if you have a extremely higher number than the benchmarking it has. So this is about the second things I'd like to introduce for this lecture about the forecast errors, the three measurements we use to evaluate how the forecast is.